Okay, so in this example, we're going to try to use the double angle identities to solve or simplify this expression. Now remember, we want to look at both sides and manipulate the one that's more complicated. In this case, it's kind of a toss-up. They're both rational. They both have several terms. So what I'm going to do is, your book picked to manipulate the right side. So you can look in your book and follow along with their steps. I'm going to pick to manipulate the left side just to give you a different example to work with. Okay, so the first thing that I want to do is I want to look at the bottom expression, since there's only one expression for sine 2 theta. So I'll start with that. The identity for sine 2 theta is 2 sine theta cosine theta. Okay. And the next thing that I want to do is I want to look at all the cosine 2 theta identities and see which one's going to work best for me. So these two involve cosine squared and sine squared, but not the other, and still a 1. So it's possible that we could maybe get rid of a 1 if we used one of these. But in this case, it's actually easiest to use cosine squared minus sine squared. So we're going to go with that. For our top, the numerator. And the reason that I've chosen that identity is because on the bottom, I have 2 sine theta cosine theta, which I can think of as the middle product of a squared binomial. If I have something like a plus b, the quantity squared, then it comes out a squared plus b squared plus 2ab. This is usually called our middle product. And on the top here, where I've got the cosine squared and the sine squared, that's usually the result of this kind of binomial product, where I get a difference of squares. So if I can spot that, that'll kind of help guide what identities that I pick. So on the bottom, I'm missing this piece, but we know sine squared and cosine squared is equal to 1, so I can add that back in. Alright, and then we can manipulate the bottom. Using the fact that we know that's a squared binomial term with sine and cosine. So this is going to be sine theta plus cosine theta, the quantity squared. And then we can manipulate the top, like we said. That's going to be sine theta plus, let's see, actually we've got cosine first, so we'll do that. cosine theta plus sine theta, and then cosine theta minus sine theta. I'll just flip the bottom around so it looks the same. So we can cancel one of those out now. Cancel one of these with this top one here. That's going to leave us with this. We'll have cosine theta minus sine theta over cosine theta plus sine theta. Now, if we look at the original, the right-hand side, we can see we've got cotangent theta minus 1 and a cotangent theta plus 1 on the top and the bottom. That's what we're trying to make this match to. We do have the plus and the minus signs in the right spot. That looks good. But this term over here and this term here is supposed to be 1. So something we could try to do is make those terms equal to 1 by multiplying by 1 over sine theta on the top and the bottom. When we distribute that through, we're going to get cosine theta over sine theta minus 1 over cosine theta over sine theta plus 1. And now we've got the identity we were looking for. That's cotangent theta minus 1 over cotangent theta plus 1. So that's the same as the right side.